Every single day, over 10,000 tons of food waste is recycled. That's the weight of more than 1,400 African elephants, processed, reimagined, and reborn, not into garbage, but into fuel, fertilizer, and even electricity. In a world where 1.3 billion tons of food are wasted each year, enough to feed every hungry person on the planet 4 times over, the question isn't just why recycle food waste, it's how do we do it at this scale? From curbside bins to industrial bioreactors, this is how over 10,000 tons of food waste is recycled every day in a factory. Let's start at the beginning, collection. Across cities, farms, restaurants, and homes, leftover food scraps, from banana peels to expired yogurt, are tossed into green bins. These aren't ordinary trash cans. They're the first stop in a sophisticated supply chain designed to give waste a second life. In urban centers, specialized collection trucks pick up these organics daily. These trucks are equipped with GPS trackers, route optimization software, and onboard compactors to maximize each trip. In rural areas, large-scale food producers like grocery stores and manufacturers ship their unsellable goods to centralized processing centers using bulk haulers. Globally, over 150 countries are now implementing food waste separation programs. In the UK alone, nearly 7 million tons of food waste are collected annually for recycling, equivalent to over 250,000 garbage trucks worth of scraps. And what they gather is massive. In places like South Korea and San Francisco, food waste is separated at the source, yielding thousands of tons per day. In South Korea, every citizen uses a weight-based food waste system, where recycling bins automatically charge users for how much waste they generate, a model that has increased recycling rates to over 95%. Once collected, the food waste heads to a processing plant. Here, the transformation begins. Trucks unload their payload into receiving bays. Huge conveyor belts feed the waste into industrial machines that screen out non-organic contaminants. Plastic wrappers, cutlery, glass, anything that doesn't belong. Magnets pull out stray metals, while air classifiers remove light debris. Some facilities even use optical sensors and AI to detect and eject unwanted materials with pinpoint accuracy. These high-tech systems can scan over 3,000 items per minute. What's left is a thick, soupy mixture called slurry. The slurry is sent through massive grinders, breaking down larger chunks into uniform particles. Think of it like a giant smoothie machine, only this smoothie is made of rotting lettuce, chicken bones, and stale bread. Why grind it? Because smaller particles break down faster and more efficiently later on. Efficiency is key when you're processing millions of pounds daily. In some facilities, enzymes are added at this stage to jumpstart the breakdown process. These biocatalysts help soften tough organic matter and increase gas yields later in digestion. This is where the real magic happens. The pulp is pumped into enormous sealed tanks, each the size of a small building, called anaerobic digesters. Here, in an oxygen-free environment, billions of microbes feast on the waste. Over days or weeks, these microorganisms break down the organic matter, producing 2 valuable outputs: biogas and digestate. Biogas is rich in methane, and it's harvested straight from the top of the tanks. It can be purified into renewable natural gas, RNG, and injected into the local power grid, enough to fuel buses, heat homes, or power electric plants. In Europe alone, biogas from food waste powers over 1 million homes. Digestate, the solid and liquid material left behind, isn't trash. It's gold for farmers. Rich in nitrogen, potassium, and phosphorus, it's spread on fields as an organic fertilizer, restoring the soil instead of stripping it. Some advanced digesters operate on a closed-loop system. The heat generated during digestion is recaptured to maintain the tank's optimal temperature, around 37 degrees, creating a self-sustaining energy cycle. Germany leads the charge with over 10,000 biogas plants in operation. In 2022 alone, these plants processed over 30 million tons of organic waste, much of it from food. Anaerobic digestion isn't new. In fact, the basic science behind it was first documented in 17th century Italy.
Today, it's evolved into a multi-billion-dollar industry, blending biology with modern engineering to fight climate change and fuel urban life.
But not all food waste goes to digesters. In some factories, especially in the US, food waste is repurposed through aerobic composting. Here, air is deliberately added to massive piles of waste. The mixture is turned regularly with giant augers, and the heat from microbial action can reach 150°F, hot enough to kill pathogens and break down complex materials like bones and eggshells. Aerated static pile systems blow air through perforated pipes beneath the compost, eliminating the need for mechanical turning and allowing for more consistent decomposition. After 8 to 12 weeks, the compost is ready, a dark, earthy material that smells like fresh soil. It's bagged and sold to gardeners, landscapers, and farms, creating a full-circle system. Some food waste is even transformed into animal feed. Bread waste, cereal, and certain vegetable scraps are dehydrated and pelletized. 1 ton of dried food waste can feed hundreds of pigs or chickens. In Japan, a single factory recycles nearly 300 tons of food waste per day into livestock feed, cutting dependency on imported grains and lowering farming costs. In the most cutting-edge facilities, food waste becomes even more. Hydrothermal liquefaction, a process that mimics the Earth's natural oil formation, can convert food waste into bio-crude oil in just hours. This oil can be refined into fuels for cars, ships, or even aircraft. Pyrolysis, which uses high heat in the absence of oxygen, creates syngas and biochar. Syngas can be burned for energy, while biochar is used to sequester carbon in soil. And then there's black soldier fly farming. These insects can consume double their body weight in food waste daily. Their larvae are harvested as a protein-rich feed for fish and livestock, while their frass, insect poop, makes a potent fertilizer. Factories in Asia and Europe are scaling this fast, turning warehouses of waste into vertical farms of wriggling insects, working 24/7. In China, a single black soldier fly facility can process over 100 tons of waste per day. That's 36,500 tons annually from one building. Black soldier fly farming is more than an experiment. It's a booming sector. The global insect protein market is projected to surpass $9 billion by 2030. And these flies are leading the charge, converting food scraps into sustainable protein with 50x the efficiency of traditional livestock. The impact, massive. Every ton of recycled food waste prevents over half a ton of CO2 emissions. When left in landfills, food rots and releases methane, a greenhouse gas 84 times more potent than carbon dioxide. In the US alone, food waste accounts for nearly 60 million tons annually. Recycling just half of that could cut emissions equal to removing 5 million cars from the road. And let's not forget water. Food waste consumes 25% of the world's freshwater supply. By recycling and reusing it, we indirectly save billions of gallons each year. Globally, the food waste recycling industry is projected to exceed $60 billion by 2030. It's not just about saving the planet, it's an economic powerhouse.
But challenges remain. Contamination is the enemy of efficiency. A single plastic wrapper can clog machines or ruin an entire compost batch. That's why public education and smart sorting systems, like AI-powered robots, are becoming standard. Some facilities deploy real-time monitoring systems using infrared and spectrometry to scan incoming waste loads for contaminants. If a batch fails, it's rerouted, sometimes to incinerators, sometimes back to source, and infrastructure is uneven. While countries like South Korea recycle over 95% of their food waste, others still send nearly all of it to landfills. Investments in regional processing centers and transport logistics are critical to close the gap. Yet the momentum is growing. Cities are passing zero-waste laws. Supermarkets are donating unsold food. Tech companies are designing fridges that track expiry dates. In Milan, Italy, a citywide food waste collection program reduced landfill contributions by 34% in just 3 years. New York City now requires large food waste generators, like hotels, stadiums, and hospitals, to separate and recycle their organics. In France, it's illegal for supermarkets to throw out unsold food. Instead, they must donate it, a move that diverts thousands of tons annually from the waste stream. And behind it all, these factories, the hidden giants, are transforming trash into treasure, one banana peel at a time. So, how do we recycle over 10,000 tons of food waste every single day? With powerful machines, ancient microbes, cutting-edge chemistry, and innovative thinking that turns leftovers into light, waste into wealth. It's not just smart, it's essential, because what we throw away can power what's next. Thanks for watching. If you're fascinated by the secret lives of our waste and want to see more behind-the-scenes factory stories, be sure to like, subscribe, and leave a comment on what we should cover next.